This is the video lesson on 16H on SI units of measurement. So let's begin by talking about exposure. Exposure is looking at the Coulomb per kilogram. So Coulomb per kilogram, we're looking at X-rays or gamma rays. Our measuring medium is the air, and the effect measured is the number of ionizations in air. The formula is the Coulomb per kilogram. For air kerma, the unit is the gray or the gray in air, and it's all ionizing radiations. And so again, we're looking at the measuring medium being the air. This one has the energy of ionizations in air, which is very important that looking at the number versus energy. And 1 gray is equal to 1 joule per kilogram. So going back to what I was just saying, the exposure is the number of ionizations in air versus the air kerma is the energy of ionizations in air. Now the absorbed dose is the gray, and something that the gray in air and gray in tissue have in common is the word energy again. Except this time, we're going to have radiation energy absorbed per unit mass. So we're looking at patient dose here. 1 gray is equal to 1 joule per kilogram. Now, if we go on to the sievert, which is the equivalent dose and effective dose unit for both of them, they have all ionizing radiations, and we're still talking about tissues for absorbed dose, equivalent dose, and effective dose. We're talking here about biologic effects. Very important thing to look at. We're looking at biological effects based upon types of radiation. So that's the one thing that's very unique about this one is biologic effects. And it's looking at the equivalent dose is the dose times the radiation weighting factor. The effective dose is the biological effects based upon radiation in tissue, and it's looking at the dose times the radiation weighting factor times the tissue weighting factor. So it includes both the radiation weighting factor and the tissue weighting factor. And this concludes our video lesson on radiation units.